Welcome back, attendees. I believe that we did not make you wait for too long, and you are all super excited for the second half of the event. So, now, time to move on to the second session. Without any delay, let's begin with our second discussion on structural engineering trends and new age mounting technologies for rooftop solar projects. And to discuss this, we have in the esteemed panel Miss Glory Agulgu, Renewable Energy Technology Training Institute. She's a moderator. Mr. Camillus Chukwuma, Power Gen Renewable Energy. Mr. Simon Graf, REF Energy. Mr. Chidi Obaik, Power Up Renewable Limited. Mr. Franz Willem Vermaak, Lumax Energy Limited. I welcome all the panelists on the screen. Before handing over to session, Ms. Glory, I would like to request you all again that, like the first session, any questions you would like to put to our panelist, please post them in the Q&A box. Our panelists will take all those questions at the end of the session. Over to you, Glory, ma'am, now.
Of course, thank you so much. Thank you everyone for being here. Good afternoon from Lagos, Nigeria. It's very sunny over here. And I hope that you're well from where you are joining from. So today we have a very exciting session, one that I'm very passionate about, because of the rise of the traction in the solar industry, because of the rise in opportunities for solar power projects development, especially in Africa and some parts of India that struggles with lack of access to electricity. So you find that there has been positive attention to these areas. In Africa, for instance, we have 600 million people without electricity access. In Nigeria, we have 77 million people without access. Right. And we are in a very favorable position in the equator as Africans and some parts of, I'm not very sure about some parts of India, which makes solar power a very efficient way to cover the energy gap, right? But that has led to a lot of ideas, a lot of conversations, a lot of innovation within this industry. And so that is why we're having this session today to discuss with these experts and understand what that journey has been. What are the specific challenges with solar power installation as it relates to rooftop solar mounting, right? I am from the Renewable Energy Technology Training Institute, and we talk about things like this all the time when we train installers, right? We think about types of installation, types of platforms for installation. We think about rooftop installation, we think about surface installation, we think about field installation, we think about solar farms. And so it's important to drive knowledge about these types of platforms for installation. And so I'm very happy today to welcome my panelists, whom have already been introduced, but I'll go ahead to call their names again. I have Mr. Chidi Obike, founder and CEO, Power Up Renewables. Thank you for joining. I can see you right there. You're welcome. We also have Mr. Franz Willem Vermaak. He's the director, Lumax Energy Pty Limited. And we have Mr. Simon Graf, the head of engineering, Area Finergy. We have Mr. Cornelius. Of course, you're welcome. I'm so sorry for speaking so fast. We have Mr. Camillus Chukwuma, who's the project manager from the Power Gen Renewable Energy. It's amazing. These are all experts, they're all engineers who can speak on this subject matter from today to tomorrow. So please get your questions ready. Personally, I'm very excited because I'm going to be learning as well. And we will go straight into it. We have about 7 key discussion points. And I'm going to start now with Mr. Simon Graf. I will quickly get across to the first question. Please give me a minute. Right there, I'm almost there. But I'd like to thank you all for joining once again. I want you to think about questions around installing solar PV, questions around mounting, questions around tracking. I'm talking to to the participants now, whilst I try to find my first question. Okay, right there. Yeah. Yes. So I'll start with Engineer Simon Graff. Thank you for joining. I'd like to ask you this. What are the types of substructures utilized in rooftop projects? Thinking about substructures and thinking about the vastness of roof types, right? So what can you share with us about this? Feel free to make examples. Thank you.
Sure, thank you, Gloria. Yeah, let me just quickly introduce my company. So I'm the head of engineering for Aria Finergy. I'm calling you from Nairobi in Kenya. We are an award-winning homegrown solar company here in Kenya, working across East Africa. We've done more than 12 megawatts of projects, growing very fast. We are a solar EPC company, and we have big plans across the region, and very optimistic about the market in this region. We're doing solar projects for a wide variety of different industries and different types of technologies. So to answer your question, I think there are many different types of roofs that one encounters doing solar projects, and as a result, many different types of mounting structures that one needs to use. So the most common that we encounter here in Kenya is the what they call the IBR, trapezoidal corrugated roof sheeting, metal roof sheeting. And in that case, normally what you will do, there's a couple of options of your substructure there. What our preference is to use a structure that connects, drills into the purlin, which sits below the roof sheeting, which gives you that extra structural security. And then from that connection, you'll then have a rail type structure, which assembles underneath the panels, and the panels are fixed onto the rails. That gives you, some security of the structure. You're not dependent on the condition of the roof sheeting. Something that we encounter commonly here in Kenya is that the roof sheeting can be of poor quality. And so, you don't want to connect too much into the roof sheeting. You want to use the roof structure itself that gives the roof its strength. And that way you guarantee that the modules, the panels are firmly secured. And whether there's a download or an upload onto the panels, they will be secured. Another type of structure you can get for metal roof sheeting is it's like a little bracket that drills into the roof sheeting, and the panels can get mounted directly onto that. We don't prefer to use that just because, firstly, it depends very much on the integrity of the roof sheeting, and secondly, it makes a number of penetrations in the roof sheeting, which can result in more holes and water ingress into the facility below, obviously, which you want to avoid for your client. Then, depending if you have a different type of roof sheeting, so you get also what's called a concealed fix standing seam roof sheeting, and that's where there's a sort of a rib that folds over. The sheets don't have any holes in them from screws. One folds over the other, and in that case, you have a kind of a clamp which clamps onto the ridge of the roof sheeting. And in that case, you can do what's called on clamp mounting, where the clamp fixes onto the roof sheeting and the panel sits directly onto the clamp, and you fix it on there, which significantly reduces the costs of the mounting structure because you are not using the rails. You're there really depending on the structural strength that you get from the ridges in the roof sheeting, which kind of act almost similarly to what your rails would do. So that's your metal roof sheeting. Another common type of roof you'll encounter is a flat concrete roof. And in that case, you'll use usually a ballasted structure. So that means the structure is not drilled in at all. You have little tables that you made to the angle that you want. So that's typically, 5 degrees, 10 degrees, 15 degrees, whatever you like. You place them on top of the concrete flat roof, and then you secure them with weights. So usually little concrete blocks that secure them in place. And the modules then attach on top of those structures. A nice benefit of this type of structure is that it's very easy to remove, and it doesn't do any damage to the roof that it's fitted onto. It can be a little bit more expensive than the metal roof sheeting type, but it's a good option if that's the type of roof the client has. There's a little bit of extra technical requirements there. You need to be able to calculate exactly how much weight you need in ballast to secure the modules in place. But usually the suppliers of the structures can assist you with that. And then the other type you'll encounter for roofs is tiled roofs. That's usually on smaller systems. We don't encounter it frequently with very big systems. That is similar to the metal roof type, where you have a rail substructure. And there, what you need to do is often you need to move the tiles out of the way, fix a bracket into the wooden purlin, which sits below the tiles, and then slide the tiles back into place. A little bit more difficult to do. Takes a bit more expertise from your installer, and has some risk of damaging the tiles. So that has some challenges as well. But nice, looks nice once you've done it. And then that's the main types we come across. We do see occasionally that installers will angle a mounting structure on a metal roof up from the angle. I mean, normally we put the panels in plane with the roof sheeting, which means they're at exactly the same angle. Sometimes they're elevated a bit. That's also uncommon. But yeah, those are the main types that you get with your metal roof sheeting, your flat concrete roof, and your tiled roof.
Wow, amazing. This was like a small mini lecture. Thank you. Thank you so much for sharing all that. There was one of the roofs that you described, which you said was not very recommended. I think it was the concealed sheet. No, the bracket type that drills into the sheet. Why is this one not recommended? Is it because does it damage the structure, or what is I'm just trying to expand on that so that people can understand, but can you throw more light on this type of this second one, the bracket type?
Yeah, absolutely. So no, not at all. So the type I'm talking about is a type that a little bracket. It often has 2 or 4 screws that screw into the roof sheeting only. So there'll be short little screws, and the bracket drills into the roof sheeting. And I think the challenge with that one, there are a couple of issues. The one is that you're making many holes in the roof sheeting. And, whenever you're putting something on a roof, every time you make a hole, you create an opportunity for water ingress. So you really want to minimize the number of holes that you make in the client's roof. It does extra damage. There's always chances for more rust. So that's one issue. And the other is that, so the main thing you're worried about with a roof mounting structure is when the wind comes through and it tries to lift the panels up. That's really what you're designing against. And when you drill into the roof sheeting only, you're really dependent on that roof sheeting is securely fixed and that the roof sheeting is structurally sound. And that's very difficult to guarantee. You can't really be sure that the roof sheeting itself is designed to be able to take that kind of uplift force, and that every screw that's holding the roof sheeting in place will remain in place if a really strong wind comes through. So, the way to bypass that is to then have a mounting structure which goes directly to the purlin, which is now the metal substructure, which is really the part of the roof that is designed to take, load. And then you guarantee that you won't have any issues if the wind really comes through strongly.
Perfect. Amazing. Thank you so much, Simon Graf. That was very enlightening. I would go over to the next panelist, and I'd like to ask Mr. Franson, what can you tell us about trackers, right? Thinking about trackers in for rooftop solar systems. Are there trackers being used? Are there trackers being utilized for solar rooftop system? And why do you think that is? You have the floor now.
Yeah. Hi, Glory. Thank you. Trackers can be utilized, and now we're talking single-axis trackers. Theoretically, they can be utilized for rooftop systems. There's no particular reason why not. The question is whether there is sufficient suitable application. So trackers are designed originally for utility scale projects and typically large projects. You've got control systems, and larger projects scale these rates of the control systems so they become affordable. Small systems are problematic, and small systems would typically be sub 200 kilowatts, something like that. The control system does scale well. So this is the first thing. Rooftops are often not large enough to accommodate tracker systems, single axis tracker systems. The second thing is the founding methods, or the way that you connect the tracker to the rooftop. Now, rooftops, you get all these kind of rooftops like Mr. Graaf just ran us through. A lot of them would just not be appropriate to even think about mounting structural elements to that are large. So on a roof, tile roof, for example, you mount fairly small brackets that's attached to beams, purlins, and battens. And on a metal roof, you also have fairly small point loads that is distributed very well across the roof. And the purlins and the steel substructure and the portal frame is designed for distributed load. You don't put beams and moments onto these roofs, you're going to influence the design of the roof significantly, and it's almost guaranteed the roof won't be designed to handle those moments. So the one place I think where the conversation really happens, and where we have seen these trackers on rooftops internationally on concrete roofs, flat concrete roofs. Now, Simon also pointed out that concrete roofs typically utilize ballasted systems. And one of the biggest reasons you utilize ballasted systems on concrete roofs is it's a delineation of responsibility or liability around the waterproofing. There's nothing wrong with drilling into a concrete roof if the waterproofing process of ensuring that anchor is sealed correctly is done well. But once a solar system is up and there's a leak and everybody starts pointing fingers at each other, the solar EPC doesn't want that liability. So ballasted systems are very popular for the sake of that. We certainly, as Lumax, have supplied many systems where anchoring has happened with chemical anchors into concrete roofs. But to get back to the tracker point, a tracker is not the lows on typical tracker designs are not appropriate for ballasting. The ballasting is too much. You're talking about tons per anchor. It's not something you want to put in a single point on a roof as a point load. So this means that things have to be redesigned to go onto concrete roofs, which has happened in some European and American places. And for me, the question is, do we have enough flat concrete roofs for this to happen in Africa? Or would people rather just move to open land, which we have plenty of?
Amazing. Amazing. Thank you. Great question. Great analysis of the question, and very good reflection of what was also previously said by the previous speaker. Thank you. Thank you, Engineer Franz. I would go on to the next panelist. I'll get back to you shortly. And I would like to ask Engineer Chidi, I'd like to ask you, understanding the load-bearing capacity of the roof and suitable structures based on the quality of the roof. This is not a question, it's just a discussion point that is open-ended. What do you have to say about the load-bearing capacity of the roof and suitable structure based on the quality of the roof? And I think this point is very important. I'd like to share a quick example about the installation that we did recently. And for the first time, I saw that there could be differences. This was earlier on in my career, and I saw that this particular roof was shaped this way, and not up to many of our installers couldn't get on that roof. But a different type of roof, we saw that a lot more of installers can get on there. So it was new to me at the time because our installers had to stay a certain way to fix the panels or to do a certain way. So I was very happy when I saw this topic here, and I would like you to just share, to throw some more light into it, load bearing capacity of the roof. What structures are suitable? Are there types? Are there quality of roofs that are recommended for certain types of load? Thank you.
A very important step in choosing the good quality structure is to do a proper initial detailed site assessment, firstly
Mhm.
by the solar engineers, whereby they do some checks on the roof, the type of roof, because you can have asbestos roof. We have seen factories that have asbestos roofs,
Okay.
then very old roofs, you know. Then
Okay.
they also have to check the beams, the structures, the substructure holding the roof. With this information, this preliminary information, you have to. It's very important, especially for CNI projects,
Mm.
to employ the services of a professional civil engineer to do a structural analysis of the building, the pillars, the load carrying capacity of the roof, and also the building itself, to ensure taking into cognizance the amount and load of the solar panels you want to install on the roof.
Okay.
We have
Mhm.
seen situations whereby in factories, maybe a factory has an asbestos roof. From the structural analysis, it was seen that those asbestos roof have to be changed to aluminum roofs. Then the beams under the roofs also you have to add. It was recommended that braces, metal braces, be added at intervals to reinforce the roof. So these are all the
Yeah,
recommendations you get when you use a professional civil engineer, because most solar guys, solar installers, companies are mostly tilted to the electrical side, mostly. So you need to
that's
get
true.
a proper, yes, a proper civil engineering assessment with a report. With this, you can now say, okay, uh, do I need to what type of this will determine the most suitable type of roofing mount structure you use, whether ballasted with a concrete roof. For instance, the concrete roof, the civil engineer will also check the weight of the ballasts and that are going to be installed on the roof, and make sure that everything is appropriate and won't fail going into the future.
Yeah.
So this is a very important step to take. And sometimes we see a lot of this is not something that is done
One day.
frequently, yes, in the industry. But it's a very critical step, especially when you're doing large scale CNI projects. You have to employ this step and use the input to choose the suitable roof mounting structure to go with.
Amazing. Thank you so much. What about in a situation or in a case where the customer, let's say it's not a CNI, could not afford to do that full change of a rooftop, for instance? Are there ways to minimize these challenges? Like one of the roof types that Mr. Simon explained, are there ways that some other types of accessories can be placed on the roof and the panel installed on it? Will it be stable enough? And I'm just thinking about the customer now. Is there a way to navigate out of this? If it was a household installation, for instance, what would you do if you were the one?
Yeah, yeah, if it was a household installation, maybe with an asbestos roof. It now also depends on how old this asbestos roof is,
Yeah.
because you don't want to shoot yourself in the foot. So you need to check if the roofing sheet is not so old, you can use a rail system that is screwed to the penetrate and screwed to the beams of the roof. So the roof itself, the roofing sheet itself, do not have much contact. Regards to the load of the panels. So it's the substructure of the beams of the roof that actually bear this weight. We
Wait.
see this
Yeah.
a lot for residential solutions using
Okay.
asbestos for this. Then that is for residential solutions. That
Makes
is
sense.
basically
Yeah.
what you can do.
What can
Yes.
happen? That's okay. I mean, and for a larger scale project, I don't think it's always important to just do a full change to avoid any problems that might come from that. But for home installations, I think that In the case where the customer could not afford to but is willing to go ahead, you can think about, if the roof is not that old, the engineer can think about how to navigate that. Thank you very much for that. I'll get back to you again, but I want to ask.
Yeah, and
Okay. Yes, you want to add something? You want to add something very briefly?
yes, it's also for homes. Yes, yes,
Yeah.
for homes, it's also important because most homes, the beams, the roofing beams are wood, and they might have stayed
Okay.
for many years. So it's
Mm-hmm.
important for the engineers to also check, some sections of the roof might need the wooden beams changed by a carpenter. So these are the stuff that actually has to be checked. When you're dealing with residential solutions, we have seen cases whereby some sections of the roof have been beaten, the wood has been eaten up by termites. So you need to change those sections, especially especially if it affects where your solar panels are going to be
Yes.
installed. So
Mm-hmm.
that has to be taken into cognizance also.
That makes a lot of sense. Thank you for sharing that. Indeed, the services of a structural or civil engineer is required for this kind of thing, especially if it's for a big project. But thank you for that. I'll now go on to Mr. Camillus Chukuba, Project Manager, Power Gen Renewables Energy. So I would like to ask you, Mr. Camillus, thank you for
Yes,
joining.
ma'am.
What are some of the best suited roofing material for solar projects?
Oh, ooh, yeah.
What
Wow. When it comes, okay.
Yes,
Any other
yes,
question too?
yes. It's a two-in-one question actually. So it says, what are some of the best suited roofing material for solar power, and what metal roofing is the most preferred solar platform? And I would
Okay.
also, this is the last initial question for all the panelists. I will welcome additional comments after his own response. So please feel free to go now. Best solar roofing materials, best brands. Maybe you can also share from your experience what the good ones has been, because we have a lot of people listening today who would learn from that. Thank you.
All right. Thank you, Glory. Um, Good day, everyone. So apparently, looking at the question asked regarding the best suitable roof for solar mounting system. So for me, I think the most suitable will be the most easiest in that way. But due to the complexity of solar solution we're trying to deploy to every client, we surmount every challenge we see, and that makes us an engineer in the field. So when we're looking at the most easiest part, we are looking at where we have less risk, uh, minimal risk in short. Let's put it that way. Very minimal risk. So when you're looking at the kind of roof mounting system, you have a concrete roof, but when you're looking at the cost implication of this, it shifts away to give a clear ground for a zinc corrugated roof, which is basically the one we make use of long rails or shared rails in terms of installing the solar PV. So if you're using a long rails, it lessens the penetration on the zinc sheet. Meanwhile, you're actually aiming at the output to actually get to the beams. So by that, you have more like less ingress on the less penetration on the roofing sheet, and you're actually still anchoring to the beams of the roofing sheet. So if you're able to achieve those 2 points, it makes it very much easy for your panel to slide on the rails. Why
Hold on.
considering?
2 points because of those that are taking notes. If you're
Okay,
able to achieve what 2 points? Being able
okay.
to drill the to the roof, or yeah, for our participants.
Okay. I'll take that back then. Let me take
Yes.
this point backwards. So, what I mean by making use of a railing system, if you're actually looking at a corrugated zinc sheet, which has projected anchors where you can actually still drill in and get to the beams and the columns of the roofing structure. So if you have a length of rail, for example, the rails
Yeah.
are basically around 3 meters and upwards. So you have quite a set of them. So all you need to do is to actually get an L foot, which gives you the opportunity to place it at the upper side of the corrugated roof. With a long self-drilling screw, you can be able to get to the beams or the columns of each of these roofing sheets. So if you're able
Yes.
to drill those points down, test the integrity of the railing to ensure that it's firmly anchored on the rail. then you are good to go. It reduces the number of penetration on the zinc sheet. At the same time, it makes it much easier for you to actually install your solar panels in case if you are installing a very large arrays of solar panel on the roof sheet. So that
Amazing.
the panel doesn't have a direct contact with the zinc sheet, so it reduces overheating as well and creates ample air to actually flow underneath, with also a great advantage of allowing air to break air and allow air to pass and cause the panel to cool more and be more efficient while generating energy from the sun. So this is the easiest, like I said, is the most preferred in terms of cost efficient, but the risk associated to it is basically fall fall at height or walk at height is basically the hazard involved in it. So for you to actually get on the roof, you need to also have the required skill set to be able to actually anchor yourself safely on an anchor boat while walking on the roof to avoid hazard. So these are the key things there. I think I
Amazing.
just touched the two questions you asked at once, unless there's another question you want me to address.
No, yes, you have answered it. The question was, what are some of the best suited roofing materials? So you said that the metal or aluminum type of roof are the best one because of the reasons that you have shared,
Yes, please.
right? Because of these reasons you've shared. Okay. The second thing was, what metal roofing is the okay? I think you've answered the two. Thank you
I know.
so much for that. You want to add some more thing, something else?
Yes, I know. Simeon actually spoke a whole lot about the
Yeah.
general roof structure and profile. Yes, he actually did justice to it, but I know he omitted some basic roof sheet that we also encounter on site when we are actually installing projects. Basically, just like the last speaker said, asbestos is also inclusive when it comes to Africa. And when you're looking at for the integrity, when you're looking at the integrity of the roofing sheet, there are a lot of things you need to consider, and likewise the load bearing capacity of the roof. First and foremost, like my other colleague said, you need to conduct a technical site assessment. You need to send an engineer to site prior before installation of that particular project to actually look at the roof sheet available, consider the framework of the roofing sheet, check the beams and columns, verify if the thickness of the roof can actually accommodate or rather house the screws that is going to be there, then calculate the weight of the entire solar panel module against the capacity of the building. So there are a lot of things you need to consider before actually getting on site to actually do a project installation there. So when you have considered all these things, calculate the weight of the panel, inclusive the rail. So one essential thing again is mostly in Africa, we like to cut corners. So some installers out there basically just go fabricate rails themselves. So some of those rails need to also be inspected and ensure you're using a standard railing system for installing your solar panels on the roof sheet. So when you have gathered all this information, you will now be in the best position to either advise a client to change his roof due to the roof
Yeah.
inability to withstand all that, or you will now choose the best structural mounting system that fits into that particular profile the client has. So this is not one method fits it all. Each client has a
Yeah.
specific and unique.
Special need.
Um,
I agree.
okay,
Absolutely. Specific need, yes. I am just agreeing with what you're saying. But
okay.
what do you think about a quick question? What do you think about? I like the point you mentioned about some installers trying to cut corners. And I think that the reason they do that is because of financial challenges from the customer. Solar power projects are still a bit expensive, and you still have customers who are not able to pay, but they are willing, right? And you find these customers wanting the price to reduce. They're asking the installer, how can this price reduce? I really want this. How can this price reduce? So you see that these installers are trying to come up with other means.
Okay.
So, what is your advice in that kind of case? The reason I'm asking this is because there are installers on the call. It's
Okay.
important to learn from one another. How have you dealt with this kind of challenge? Even if you're not dealing with it now, because maybe you have a bigger role or a new role, when you were starting out as an installer, what did you do? Or how did you just do this? I know an installer who told me something that he did with batteries. We're not talking about batteries now. but these are realities. These are things that are going on. And the reason this conference is happening now is because we need to talk about what is going on in the markets, realities of people on ground, right? Beyond what is said, written in paper, beyond what we teach. I'm a teacher. Beyond what you teach in the classrooms, these entrepreneurs actually have a lot of differences from the classroom than what is happening out there. So how have you dealt with this kind of challenge when there is that situation between price and doing something that is quality or something that would last?
All right.
I
Thank
don't know if
you.
I was able to ask the question properly, but
I
I'm
understand
sure
your
you know what
question. I understand it
yes.
perfectly fine. I have
Okay.
encountered, I won't say thousands, I've encountered quite a number of such scenarios
Situations, yeah.
during my project days as a project engineer. So I've encountered a whole lot of that. But mentioning but few, the way I actually treat these things are customer related. So you need to understand your client's need and capacity. When it comes
Very
to
good.
solar installation, we have modular solar systems. You cannot afford to, if once you can't afford a particular mounting structure, there is another mounting structure that speaks to what you have. Yet, why mentioning that? You need to also explain to the customer the implication of stepping down to this particular mounting structure. So, typical example.
Yeah.
Let me cite one typical example. There was a client of mine I installed a system for some years back. The client actually has asbestos roof. I didn't do the, I wasn't opportune to go for the site assessment, but basically I just gave him a quote and I said, okay, you have sufficient roof space? Yes, said yes. I said, before I install, I need to equally see. The lady vowed that the roof sheet is standard. Good.
Yes.
So on getting to site, I basically got up the roof using a scaffolding process. When I got there, I took a very clear picture of the roofing sheet. I came down. I sat the lady down. I said, Ma, this is your roof. Your roof is bad. So you need to understand it from the onset before you actually jump into it.
Yes.
I'm not
Yes.
greedy when it comes to trying to make ends meet and compromising the quality of the job because the quality of the job will speak for you even when you're not there. So
That's
I
right.
told the lady, your roof is bad. We have already procured this item. If I leave them on the floor, is a waste. The best
Yes.
approach to this is either you are changing this asbestos to a brand new asbestos, or you're automatically changing it to a zinc sheet. She said, how much will it cost her to change it? I said, I don't mind holding on for you to actually correct this. And
Interesting.
based on the rapport we have, because you need to understand your client. Yes, you're trying to provide a solution, not
Yeah.
going there to create more problem for the client. So if I had gotten up there and
Nice.
attended and kept on installing those systems there, and unfortunately have an accident or maybe one of my engineer fell from the zinc sheet and landed on the floor is a hazard. And the client will not like to hear such a story and may not even be able to get out of it once the
That's
law
right.
enforcement agencies start chasing everybody, including
Yes.
myself.
Thank you.
So, but on a serious note, we need to be what honest with the client.
Yes. Tell them.
Sincerity is key. Be open. There is nothing hidden there. Ma, your
Yeah.
roof is usable, but these are the challenges we need to face. When you are open to a client, it builds confidence.
That's true. And they trust you more. I really
But
like
if
that.
you're
Sorry.
not able to build that
Yeah.
confidence in your clients, you will lose out.
Yes. That's true. Thank you for throwing more light into that. I think it's very important what he has said. Being honest with the customer, what has to happen, what is on ground, and how to go about it. Because that would speak more, not just for the benefit of your customer, but for the reputation of your work. Thank you for sharing that. Before we move to the next one, I'd like to invite our panelists, Mr. Simon. Do you have something to add to this question? Do you have something to add to what Engineer Camillus have said? some of the best suited roofing materials. Do you want to share any examples? The most
Yeah,
preferred.
absolutely. Yeah,
Yes.
Gloria. I mean, I think if you gave me a choice of the roof type that I would most like to work on, I'd mentioned before is the standing seam metal roof sheeting. And the great benefit of that type of sheeting is that you can install mounting structures without drilling any holes in the sheeting. The ridges of the sheeting have a shape. They've got a kind of a bulb at the top. And so the way you secure the structures to the roof is by clamping over this bulb. You don't make any holes. And as a result, you do no damage to the roof. The risk of water going into the roof is basically zero. It's very easy to remove if you ever have to do that. It's very easy to adjust. The roof is very strong to walk on, safety wise, it's really good to work on. So if you gave me a preference, I would absolutely go for a standing seam roof. It's fairly common in South
Yeah.
Africa, less common in
Yeah.
Kenya, though I'm starting to see it it's coming up in Kenya. But that's really, from my point of view, ideal for solar. It's cost wise, safety wise, in terms of the risks of damaging the client's property, it's really the best.
So even if the roof is bad, can this option still work? Do you still prefer this option? Or do you have to change the roof altogether before you can use this option? How does that work?
Yeah, I mean, I have not come across so many roofs of this type that are in bad condition. Normally, unfortunately, you generally go back to the client and say, really, this roof is not safe to use. We suggest
Yes.
replacing it. I think maybe just to add to what my previous colleague had mentioned there, I think there are different ways to reduce the costs for the client. And nowadays there are many types of financing options. That if they can't afford to pay for the system up front, there's ways to get loans, there's ways to get financing, there's kind of leasing, there's lease to own. So you really can find a way to make it work financially. So if the client's roof is poor, you go up there and say, look, it's not safe to have a solar system on here. It's not safe for our team to work on here. Probably you would need to replace the roof in 5 years anyway, and we want the system to last 15 or 20 years. So let's see how we can build that in. You say, okay, well, let's include this as a cost of the project, and how can we make that make financial sense? So we'll put it in. Maybe we pay for the roof sheeting replacement, but then it'll be built into the project cost and paid off over a certain time. I think nowadays we see that there's a lot of financial ways to overcome some of these issues more than the technical way.
That's true. Wow. Thank you for throwing light into that. And I want to ask if Mr. Franson and Mr. Chidi has something to add to this. If not, we can move on to the next question. But please, Mr. Franson, sorry. Yes.
Right. I'd like to say something. So we work quite closely with major roofing manufacturers in Southern Africa. And the roofing manufacturers actually specify their clip lock, which is concealed fixed roofs, as their preference for solar product. So this is industry understood and known that concealed fixed roofs are the preferred option for solar installations. Various reasons. It's the most cost effective, it's the easiest. The roofing manufacturer has the capability to uphold a warranty. So these roofs comes with warranties of typically 5-year installation warranties and 10-year material warranties. The roofing manufacturer can uphold that warranty. They only uphold those warranties on concealed fixed roofs, where you don't penetrate the roof and you don't put extra holes into the roof. So even though it's not the prevalent roof across Africa, that would be sub-Saharan Africa and Africa north of South Africa, I think it will be roofs that will be the prevalent roofs in the future. So new builds typically go to concealed fixed. They are quite similar in cost to pierced fixed roofs. They have various benefits in terms of long runs. So there's better expansion capability of the roof sheet to the substructure. You can build much longer roofs. IBRs get fixed down at specific points with pierced points. So you're not supposed to build very long roofs out of trapezoidal IBR roof sheets. So there's a clear winner in my opinion. Yeah.
Wow, amazing. Thank you. Thank you for sharing that. You did mention a name of a manufacturing company, did you? Did you mention a name of a roofing manufacturer? You can please,
I
if you
can
could.
tell you that
Yeah,
the primary manufacturers in South Africa
yeah.
for roofing, roof sheeting is Global Roofing Solutions, or GRS, and Safintra. They are probably the biggest manufacturers. Safintra actually has they've got molds in East Africa as well,
Okay.
as a steel mill. We've got some other manufacturers in South Africa like Cloten Steel, Pro Roof, um, Max Steel. Those are probably the main roofing manufacturers in the country.
Amazing. Thank you. Thank you so much for sharing that. I'd like to ask Mr. Chidi if he has something to add. Engineer Chidi, are you still here? To the
Yes,
talk about some of the best roofing materials. Yes, please.
yes, like my other colleague mentioned, the metal roofing with standing ridges, is actually the best because you can actually just clamp uh,
Yeah.
your installation. You don't penetrate the roof and reduce the risk of water ingress into the roof, and it's quite easy. It's an easy installation and quick. It's quicker because you don't drill, so the timeline is better. So it's actually the best methods.
Okay.
Best
That's
roofing
this.
methods.
Okay. Seam roof sheeting, right? That one. Yes.
Yes.
Okay. Thank you. Thank you for that. Also, what I've noticed from all of the panelists is that understanding your market is very important. I can see from your responses that interacting with your market and the people that you work with have also informed the kind of way that you engage with them. Also, taking into account all of the things that's been mentioned about roof quality, roof age, I think that when you continue to engage for our participants, you would eventually come up with your own story. You would see something that is working for you, financially wise, product wise, brand wise, availability wise as well. So thank you all for sharing that. I want Rajashri to please remind me how many more minutes that we have. We have about three more talking points, and I think I'll go to the next one. But I'd like to know how many more minutes we have before we continue. Can anyone help me? It's a 1 hour section. I think we started 42 minutes ago, but I'm not sure now.
Ma'am, you have 15-20 minutes.
Okay, good. I was correct. Yeah, 40 minutes. So I would like to go over to Mr. Simon Graf. Please, now it's time for us to learn about case studies, examples from your businesses, examples from something you've done before about rooftop solar structure designing. I also feel like we've also talked a little bit of that, but it's important. I'd like to hear stories, case stories about how you have deployed this kind of solution, how it has worked out, if a problem came up later on, how you fixed it. Yeah, please share a case study example with us, Mr. Simon.
Sure, Glory. Yeah, let me think now. I mean, one that comes to mind, and it speaks a little bit to some of the points that have been raised earlier. We did a project for a flower farm in Kenya. And there's a lot of questions here about what do you do if the roof strength is not sufficient, or the roof is not in good condition, and so we did this project, and we did so the first step in any project is you engage, once the client signed, of course, you engage a structural engineer and you ask them to do an assessment of the roof. Is the roof suitable for solar? Can it take the additional weight? And we did an assessment of this roof, and the feedback was you cannot place solar across the entire roof. But however, if you limit the areas where the solar is placed, then you can still go ahead with the project. So that was quite a good solution because, in this case, the client would have to have spent a lot of money to reinforce the roof and add more beams and more substructure to increase the strength. And we were able to say to them, look, what the structural engineer said to us is that we can build 1 meter on either side of the truss. So, just for those who are not familiar with roofing terminology, the beam that goes across the roof, the first one is your truss. That's your principal kind of load-bearing member. That's what stands on top of the pillars. So you have the pillars coming up. You have your truss on top of the pillars. On top of the truss usually goes the purlins. which run along the roof, and then the roof sheeting sits on top of the purlins. And we were told, you cannot cover the entire roof with the solar panels, but you can build close to the truss. And so we were able to design a solution where, we limited the area of the solar just over the trusses. And, it was sufficient in the end for that client, for their power needs. It worked out well. They didn't have to do any additional work. And as a result, we were able to do a system for them where they didn't have to put in any cost. And that project worked out, very well for us. The client was very happy that we were able to come up with a solution for them. And then in that case, they came back to us later and asked us, to expand the system, and add on to it, once they had more power consumption. So, by applying that, there's simple things you can do. You don't have to come up with a very fancy, over-engineered sort of substructure to solve. Sometimes it can be just limiting, where you place the panels. That can be sufficient. I think it's something else that comes up a lot, at the moment is walkways. And if the roof is weak, that you put a walkway down that you can walk on it. I'm trying to think of another case. I think. The roof sheeting thickness is something that comes up quite a lot. The gauge of the roof sheeting. It can look the same, but you get different thicknesses of roof sheeting. And sometimes we found that when the roof sheeting thickness is very thin, as soon as you stand on the roof, even though the substructure can take the weight, the sheeting itself is very weak, and can get damaged. And so in a case like that, had one or two such cases, it's important to go back to the client and say, look, there's been some damage to the roof. Here's how we're going to repair that for you, and to really maintain the relationship, because, things can happen on site. And, it's important that you go back to the client with a solution and say, there's been some damage to your roof sheeting. Either we replace it for you, we find a way to repair it, or we work out a solution that works out the best, for them. So it's really important to just maintain the trust of the client, understand what you're dealing with. If problems occur, which they can occur, when working on someone's roof, it's very easy to drop a panel, do some damage. You really want to act on that and make sure that you find a good solution, you work together with the client, you maintain their trust, and you really come up with a solution that works well and keeps them happy. And when you do that, you find that they want to come back to you, in the future.
Absolutely. Wow. Thank you for sharing that and for talking about how you surmounted the challenge that came up. I was going to ask, how did you arrive at that solution that you eventually gave to the customer? Why didn't you think of that solution beforehand? So what were those steps that you took? I'm always thinking about how the participants can think structurally or constructively during a problem. So what changed? How did you arrive at that good solution that helped the customer? Thank you.
Yeah, look, I think in a lot of cases, prevention is better than a cure, and you really want to be able to identify beforehand any issues that could occur with the roof. One thing I find very, very valuable, and I'd recommend to any installer, is to do a very thorough inspection of the roof before you start working. As Frans had mentioned, if you do an installation and there's water starts coming through the roof, the client will immediately point their fingers at you and say, well, you've done something here, even if it might have been an existing problem. So what's really important is inspect the roof. If there is pre-existing damage, which there often is, I would say the vast majority of roofs that we encounter have pre-existing damage. They've got dents, they've got holes, they've got rust. Is do an inspection beforehand, you identify that damage, and then you show the client. You work together with them and say, hey, look, let's agree this is what was pre-existing damage. We know now that was there before we started work. If anything new comes up that's not what we had identified before, then we would take responsibility for it. But it's very important that everyone agrees ahead of time. This is what was there before. This was the condition of the roof. And any changes to that would be for the installer's account. But if it is at the condition it was beforehand, then that's obviously for the client to sort out.
Absolutely. Thank you. That is very, very helpful. I want to call on other panelists to add to that case studies of rooftop solar structure designing. Mr. Chidi, you want to speak? I
Okay.
see your hand is off.
Yes.
Yes.
Okay. So
Case study.
we worked on a a factory project, 950 kilowatts peak, like five. In fact, it has 5 different buildings: the main factory building, then some other sub factories, and an administrative building. So for the main factory building, it was mainly asbestos roofs.
Okay.
So we recommended, because we after the inspection, a civil engineer came, did structural assessment of the whole 5 buildings, recommended changes to be made. Like for the main factory, recommended that the asbestos roof should be changed to aluminium roofing sheets. Then also the substructure, the metallic substructure, braces to be added to be able to carry the weight of the uh, solar panels.
Yes.
Then, then for some other buildings of the factories, those were actually aluminium also. But the civil engineer recommended that we include braces
Okay.
into the metallic substructure, the beams of the roof for those other factories. But we didn't change the roofing sheets because those were aluminium of a sufficient thickness. Then the main administrative building, that one could take like 100 kilowatts peak, but the wooden beams were old, and rusted.
Okay.
And we're talking of a solar project that should last 30 years plus. So we recommended that the whole wooden beams substructure, the whole should be changed, to aluminium, and also the asbestos sheet should be changed to metal, to aluminium. Then also there's another like administrative building also that had the same issue. We had to change the whole substructure, wooden beams to metal, and the roofing sheet from asbestos also to
Wow.
aluminium. Then we also found out that at the top floor, you know, the wooden beams, there were no lintels in the building. So the wooden beams were actually placed on blocks itself. So reinforcement had to be done, whereby lintels were put in and stuff. So these are some of
Things you
the
understand.
steps we took.
Okay.
So that's why I always
Emphasize.
reinforce the fact that you need to do a proper, especially for large project,
Yes.
professional civil engineering analysis, structural analysis.
Yes. I agree. And I think that if there is one important takeaway from all the participants today is just that do a proper monitoring, or what's the name called? A proper
Analysis,
assessment of the roof.
structural
Yes.
analysis.
Thank you. So that you can understand what the situation or state of that roof is in. I'll take final comments from Engineer Franz and Engineer Chuku Emeka. And if we have more time, we can take one more question, but I don't think we have more time. So, Mr. Franz, what do you think about? Do you have any story you can share with us? A case study of, I'm trying to look, of rooftop solar structure designing, thinking about all of that. What happened? What steps did you take? Have you come across a very troublesome customer? What did you do? Thank you.
Thanks, Glory. Yes, so we've supplied many thousands of projects as a mounting structure supplier. So we've actually dealt with a host of problematic roofs.
Yeah.
I think the problem we've solved a few times is when the purlins are under-designed, which means can't add additional dead weight or additional kilograms to a roof in the form of solar panels, because the purlins, according to the structural engineer that designed the building, is very close to its holding capacity. Very often what we see is the purlins are the problem, but the trusses are sufficient to take extra weight. So I think Simon explained it earlier that the roof structure, the trusses sit below the purlins. The purlins are the members directly below the sheeting. But what we've actually done quite a few times is utilize bigger members. So typically the rooftop industry utilizes quite small brackets, maybe 50 millimeters high rails um, and brackets. But we, for example, manufacture much higher rails for spanning 4 or 5 meters in ground mount applications, and we also manufacture carport rails, which can typically span 7.5 meters. So you could
Mm-hmm.
utilize these members on top of a roof and build a superstructure above the sheeting. The challenge comes down to connecting this back to the substructure of the sheeting. Um, so the solution that we found most of the time is keeping the loading close to the trusses. So you connect to the sheeting or the purlins in the vicinity of the trusses, and you span the span between the trusses. I think we're doing a project which we did about a megawatt, 1.5 megawatt a year ago, and we're doing another 3 megawatt on that roof. We're probably manufacturing that next week. But in that
Wow.
case, we are clamping in within 1.5 meters of the trusses, and we are leaving a 2.5 meter gap in between the spans. And this was a negotiation between our engineers and the building or the owner's engineer for the building, and everybody was happy with this. It actually worked.
Yeah. Wow, amazing. Thank you. Thank you for that. And Lumax Energy, guys, is a manufacturer of PV mounting technologies. And I think it's very exciting to hear from you directly talk about these things. I would recommend anyone who is in need, people to make inquiries with you, right? If your email is available, when they want to find information about mountain structures. I just saw that online right now. Okay, thank you for that. Excuse me. I want to ask the Mr. Chukwemeka, do you have any case study at all when you're talking about rooftop structures, rooftop design, installation of rooftop? Do you have any stories at all that you can share with our participants? Problems you encountered, how you solved them. Thank you.
Okay. Thank you once more. Chukuma is the name, not Chukwemeka.
Sorry,
Anyway,
please. My apologies.
um, I actually cited a case study the previous time I had the audience to speak with everybody in the call. Uh, Actually, on a journey, because as a project manager, I'm on a journey in the solar
Yeah.
world. So I see various scenarios on daily basis. So, typical example, I can go ahead and cite another typical example I encountered, which is it has to do with a very steep roof. So steep roof in the sense that the angle of inclination is very steep in a way that you find it very difficult actually working on a very steep roof. So the chances of you falling from there is very high. So that was a case study I met in a client's apartment. And apparently, the client has quite a landmass, free landmass. So when I met that structural problem, I told the client that these are the prevailing challenges we're going to face. First and foremost, the angle of inclination to the sun is very bad. So we're not going to get more generation from that particular inclination. Two, once the sun goes over, the panel starts generation will drop drastically. And above all, maintenance purposes become very much difficult for any engineer to actually come and clean the panels when the time is due. So the solution I suggested, hey sir, yes, I know we're installing way over 30 kilowatt peak for you, and we can actually still make use of this panel and convert that to more like a tourist attraction for you and as well more beneficiary to you as well. Why not we tilt towards a carport solution? You have the land mass. It only cost you upfront to actually get this installed. And he loved the idea. He said, wow, he never thought about this. That how will it look? What's the finishing like? I said, okay, you know what I'm going to do? I'm going to draw out a SketchUp drawing that portray what the finishing will look like.
Looks like, yeah.
So that was a very simple way of solving a complex issue that I met with a very steep roof. Is not that it's not usable. We can actually install it there, but the benefit is not beneficiary to the client, and is also very, very tedious to actually work on if you're going back there for maintenance purposes, and there is always
Yes.
high risk of fall involving in it, which is what we are trying to eliminate completely. So a carport solution was designed, and up to today, the man is always great. Hey, I can actually park my car underneath without water touching it, even when the rain is falling. So it becomes costly, but more profitable to him and more advantageous as well. So that's just a case study speaking
That
to what
makes
you asked.
sense. Yes, that makes a lot of sense. But I'd like to ask you, you said that the steep roof was not beneficial to the client. Or is it that the problem you found with the steep roof was more risky to you and your team? Because you also said that you could install on it. What were
Okay,
the other
so
reasons why you couldn't install it? Because I remember making an example of a steep roof that we worked on my team that was just this way. It was so difficult. Our installers had to lay down to actually work on that roof. So, but before I go on to the benefits of the carport, why could you, aside from that risk to your team, why could
okay,
you not continue with that for the clients?
okay, it's pretty very simple. The reason why we install solar panel is to maximize what? Solar radiation. So when we're looking
Yes.
at the steep roof and the orientation of the panels to the sun is
Okay.
up,
Yeah. Yes.
is useless to the client. You're
I missed
basically
that
putting
point.
a pictorial diagram for him to see I have a solar in my roof, but the
Yes.
generation you're getting from it is very poor.
Okay.
So that
Perfect.
is the angle from it.
You
So it's
answered my question. Yeah. That's
okay.
perfect.
So
I missed that point where the angling is not quite right. But also for the carport as well, did you also consider all these factors and it was clean and there weren't any shadings at all
yes,
for
I
the
did.
carport? Okay. Then
Absolutely.
you mentioned, yes, you said that it was going to be a tourist attraction. How do you mean
Yes.
by
Okay, when
that?
you're looking at the aesthetics of a carport, it brings
Yeah.
the beauty of the house out. Typical example, if looking at that client alone, I know we've been able to swindle more than 5 clients within the same carport project, mainly
Wow.
coming there to see the project. Oh, wow, who did this project? It was
Okay.
Power Gen. So obviously, it was like an eye
Yes.
opener for so many people that has the finance, but looking for something that will add beauty to their existing infrastructure. So,
Wow.
and not just beauty to it, it also act it serves the purpose of actually parking cars underneath. If
Yes.
you want to do a
Yes.
party, it provides shading for you and for the domestic staff as well.
Wow. Perfect. So many benefits. There's so many benefits, and I think it's a very innovative solution if the client has the space and everything aligns. Because it will cost him a little bit more money, but he could do much more. He can even earn from it, or start a business there, or just do something with the space. I think that's a very good case study. I want to thank all our panelists. I don't know if we have more time. Please, you can let me know. But I think that I'm also very grateful that we have the topic of case studies in this discussion, because we could then see individual scenarios from each story and we could learn from it, from how Simon Graf found a unique solution to the client on how to place those panels, and from how Mr. Chidi also found problems that were pre-existing on the roof, and did a very very intensive structural analysis and was able to make good recommendations. And from Mr. Hans that has shared the challenge that he encountered and the solutions that he brought forth, and now Mr. Chukuma, the solution you brought forth, which was now more beneficial. From your stories, the solutions you guys presented had actually been more benefiting than the initial instance. I think it makes a lot of sense, and we can all learn from that. How to think innovatively whilst we are engaging with customers, and how to think about more than one solution at a time. Let's always think about plan Bs. If this plan A would not work, what other thing can we recommend to that customer? That way, if something does come up, you can have a plan, or you can actually present those two scenarios to them. So that makes a lot of sense. I want to thank my panelists again for being here today. Thank you. Over to you. I think my time is done. So I think you would then take questions now, right?
Yeah, ma'am,
Thank
we
you.
have some questions from the audience. So I'll just show on the stage and you can read and the concerned person can answer.
Okay. One question from Nsikan Atman, Solar Integrated Power Solutions Limited. One of the major concerns of solar panel installation is the type of roofing sheet and orientation of the roof structures. In cases where the roof structures does not meet the standards, what can be done to remedy the situation? Interesting. And I can see that he posted that an hour ago. I don't know if he stayed true to the session. He would have had responses to this question. Sikan, are you still here? But is there any need? Do you think there's any need for a panelist to take this? Because I think they've already covered that. Um,
Okay.
but since we have the time for questions, maybe Mr. Simon, because you're the first one I can see on my list, can you still, lay some more emphasis on where the roof has an issue, the orientation is poor? Even the last comment from Mr. Chukuma addresses it. But let's hear from you, Mr. Simon.
Yeah, sure, absolutely. I mean, we've talked about it a little bit before already, and I think, the one would be, and then the obvious one, and each of my colleagues has mentioned it, is that one does some kind of repair to the roof. You have it analyzed. The thing is also, roof repairs don't have to be that expensive. I've come across cases where there's very little that's required to do to make the roof suitable. Sometimes there's just a little bracket that you do right at the side of the truss, just a little bit of extra support, and then it's good enough. So that's the one. And then the other, as I mentioned before, is to sometimes limit, where you place the panels. They don't have to be everywhere. So if some of your roof sheeting or some of the orientation is not suitable, then maybe you skip that one and you work on another roof. You give them a smaller system. You work around their limitations, or as my other colleague mentioned, you suggest something which is not in the roof. You say, well, what about it? What about a carport? What about a ground mount structure? Why? Let's do something else for you. If the roof is not suitable. So there's a number of different options.
That's awesome. Thank you for answering that. I don't think any other panelists wants to add something. I think we've really answered that question today from all of the presentations. So can we go to the next question now? Thank you. Question to the man from Aria Finergy. Is that from this section? On the consistent consideration when it comes to the power requirements and design. How often have you been involved in setting up anchorage for clients who are setting up new facility? So,
Laura, I think that's me. I'm from Maria.
Sorry, please.
Yeah. No, look, it's great when the client can involve you right from the beginning. When it's a new build project, and you're involved in the design, from the start. So then you can really specify. Say, this is the kind of roof sheeting I want. This is how strong the roof needs to be. So then you'll give input to the structural engineer, and you'll tell them this is how many kilograms per square meter, the roof is supposed to take. You can get involved in, like I mentioned, the roof sheeting gauge, how thick the roof sheeting is. A thicker gauge is easy to work on. You can also, tell them where would the skylights be. You can make the spacing ideal for placing the roof. The panels, because sometimes you have a lot of skylights or cyclones, air conditioners, things like that in the roof, which can make it a big problem. So if you can get involved with the building design from the beginning, you can really tell them what suits you. So what space do you need? What angle do you want? What thickness of the roof sheeting? How strong should the roof be? Where should they place anything, other things that need to be on the roof? Make sure that there's nothing shading the roof. No other buildings or trees or towers and things like that. So there's a lot of input that you can give into the design, which ensures that it's much, easier to do an installation, rather than coming onto an existing roof.
Perfect. I also think that's really the best scenario in this initiatives. That's the type of place that engineers are wanting to find themselves in, especially during this time when solar has gotten so popular in Africa. And there's a lot going on in real estate. I think this is an important thing to have in mind for engineers that are on the call, thinking about approaching people in the building industry as well to work together, right? I know that I share that a lot with our students. Many of them come from different backgrounds. Some of them are architects, building engineers, civil engineers, wanting to go into the solar sector because they have found an opportunity there. So it can be a good marketing strategy to work with realties and builders so that you can start the process with them, right? And so that you can have the opportunity to actually create what you want, what will ensure the maximum output of that solar installation. So thank you for that, Mr. Simon. Let's go to the next question. My question with solar power is with the batteries disposal. We know, and that's from Veronica Edemina, Tony Pash Energy. We know that the batteries for storing the energy needs replacement after 5 years for some solar technologies. Are the batteries disposed sustainably? I think this question is for all, and I'd like to hear from all the panelists. Please keep it short because we're out of time already. So, what do you do with your batteries? Because I don't know, do the clients contact you after the batteries expire, after the batteries damage after 5 years? Do you dispose these batteries? What do you do with them, or do you leave that for the customer to deal with after it expires? I'd like to hear, starting from Chidi OBK. Please tell us what you do with your solar batteries. How do you dispose of it, or you've not had the opportunity to do that before, or you're working with an environmental management structure? Please let us know.
Okay, there's some policies have been put into place now by Alliance for Responsible Battery Recycling, whereby when batteries reach the end of life, there's a center where the batteries are taken to, for proper recycling. So this is actually the best way, to go about this. But we see a large situation occurrence whereby many batteries, are not disposed of properly. But there's actually a mechanism now in place for proper disposal and recycling of batteries. And there's actually a requirement under RIAN for all their members to sign up to this policy, whereby at the end of life of batteries, you take it to the appropriate center for proper recycling. Yes.
Thank you so much. Yeah, in your own story though, how have you handled that in your own story? So you have always taken it to these kinds of places, or you recycled them yourself, or you've reused them. Meanwhile, there is a good second-hand market for batteries. I don't know if you guys know.
Yes, exactly.
Yes.
So we normally sell it, as in you can sell it to a aggregator that now
There
takes
is
it
an option. Yeah.
to the center for proper recycling.
Perfect. Thank you, Mr. Simon. What do you have to say about battery disposal? What is your case? What is your own example? In disposing batteries. Thank you.
Gloria, I can't speak to this one too much as we haven't done too many battery projects, and those that we have done have not come to the end of life yet. I'm aware of some companies, that will take all batteries. I know there are some companies that will take back the batteries if they supplied you the batteries, and they will take them back. For example, a company in Kenya called Chloride Exide. If you're finished with the batteries, they will take back the old batteries, so they can recycle them. So in that case, I think it's best if you can have a deal with the original manufacturer of the batteries to return them for some kind of credit or recycling.
Perfect. Thank you so much. That makes sense, and I hope that this is really answering the question of the person who asked, Mr. Franz. I don't know if you work with a lot of batteries, but do you have something to say to the battery disposal?
No. Yeah. Well, what I can say is I think lead assets are well understood. The lead can be recycled. The question is probably more relevant to lithium ion, and actually, I think we're yet to see the real end of life of lithium ions and how this industry is going to evolve.
Yes, thank you for that, Mr. Also, I wanted to say that the session is mostly for PV mounting, so there aren't a lot of battery experts here. The people here would only share to what their own experience has been. But I'll give the floor to you, Mr. Chukwemeka. Have you had that scenario where you had to dispose the battery? What did you do? Or what did your company do?
Right. Thank you once more. When it comes to battery disposal, we have a particular channel which we use to dispose overused battery or afterlife batteries. So,
Yeah.
like my two colleagues already mentioned, one is back through the OEMs, then one is actually through a recycling process, or rather, a recycling manufacturers that actually receive these batteries and recycle them and bring them back to life before bringing it into the market again. So these are the two processes we actually follow at the moment.
Amazing.
Thank you.
Thank you so much for that answer. Is there any other question to the admin?
Yes, ma'am. We have a last question. I'll just show on the stage.
Of course. Ceramic roofing tiles are now being introduced in some buildings. What mounting structures are and associated accessories are currently available for such applications for ceramic roofing tiles? Interesting. Please feel free, anyone who wants to go for this question. What mounting structures and accessories are currently available for ceramic roofing tiles? Mr. France, do you have anything to add to this one? Or Mr. Chidi and any one of the panelists? Please feel free to jump in. Ceramic,
Sure, I'll answer.
yeah.
So there's three. I think the roofing tiles is a very common the roof type, and there's good solutions for roof tiles, ceramic roof tiles, slate roof tiles, all kinds of roof tiles. I think roof hooks are the most common and well-known solution, which is where you would typically move up the roof tile, get access to the raft or the beam underneath, and connect the roof hook with screws to that. And then you would move the roof tile back, and you have a piece of metal sticking out of the roof, which you can connect rail system to. For slate roofs, there's more complicated systems. They're quite hard to install, actually. Um, and then there are other types of roof tiles in other parts of the world, but I think the typical Roman roof tile is really what we see in Africa.
Okay.
Quite,
Yeah.
quite, if you look at our website, for example, you'll see very good images of the solution. It's really well understood.
Perfect. Thank you so much. And I think that's the last question. Yeah.
Yes,
Yes.
ma'am. That's it.
Thank you so much, our panelists. Thank you for joining and thank you for your amazing, enlightening contributions. We've all learned a lot. My pages are filled up with write ups from what you guys have said today. So I'd like to thank the organizers as well for putting this event together. And thank you for having me. Over to you, admin.
Thank you so much to all our esteemed panelists. Thank you so much, Glory ma'am, for the terrific and very professional example you set as a moderator. It was a pleasure having you in such a well planned and high energy panel discussion. Thank you, everyone, for extending your time and support for this event. We promise you to come back with more exciting topics very soon. Thanks to our partners, Trolar, for extending their support to organize this webinar. The floor is now open for networking. Thank you very much.
Thanks. Bye.
Bye.